Welcome back, Focus Learners, to another explainer. Today, we're looking at a fascinating story of extreme engineering battling an invisible enemy. We are exploring the incredible and, honestly, sometimes terrifying reality of the Chernobyl new safe confinement. This is a structure built to solve a problem that humanity had literally never faced before. And as we'll see, it's a solution that continues to be tested in ways its original designers could never have imagined.
36,000 tons. That is just the staggering, colossal weight of the new safe confinement arch. To put that into perspective for a second, it's one of the heaviest moving land-based structures ever constructed by human hands. It's an absolute mammoth of metal, and it was designed to do a job of absolutely critical global importance.
Okay, let's dive into this. How do you safely entomb a highly radioactive exploded reactor? You obviously can't just send workers in with concrete and rebar like a standard construction site, right? The environment is actively lethal. The radiation levels are so high that traditional building methods are just entirely impossible. This was the massive, completely unprecedented problem that engineers and nations across the globe really had to figure out. To understand the solution, we have to swiftly recount the legacy of the disaster. On April 26, 1986, a flawed safety test triggered a massive steam explosion at Reactor Unit 4. The very next day, a 9-day graphite fire began. Now, in a desperate attempt to suppress it, military helicopters dropped sand, boron, and lead, but the fire still released a massive 5,200 petabecquerels of radiation into the atmosphere. By May, 116,000 residents had been evacuated from the exclusion zone. It was, simply put, a crisis that demanded immediate, desperate action.
And this brilliantly illustrates a really stark contrast. On one side, you have the original 1986 sarcophagus. It was a rushed, improvisational concrete shield built in just a few months to contain 200 tons of uranium dioxide. And by the 1990s, it was rotting, leaking, and at severe risk of a catastrophic collapse. On the flip side is the modern solution, and our main subject today, the new safe confinement. It's hermetically sealed, designed with a 100-year lifespan, and it's entirely seismically resistant.
Section 1. Extreme Engineering and Construction. Building a permanent shield in a high radiation zone required a level of sheer ingenuity that essentially redefined modern civil engineering. But, well, before you can build it, you have to fund it. The shelter implementation plan required an incredible 2.1 billion euros. And what's absolutely remarkable here is the unprecedented international collaboration that made it happen. Over 45 donor nations, along with the European Union and G7 countries, pooled their resources together, managed by the European Bank for Reconstruction and Development. Out of this total, a colossal 1.5 billion euros was allocated specifically for the new safe confinement. So you might be wondering, how did they actually build it without exposing workers to lethal doses of radiation? Well, they broke it down into 3 brilliant steps. Step 1. They prepared a clean zone adjacent to the damaged reactor, laying down concrete slabs to shield workers from ground contamination. Step 2. They assembled the giant arch off-site, right in this clean zone, in 2 massive halves. And Step 3. They joined those halves together and prepared to slide the entire structure 327 meters into place. This whole process was governed by strict ALARA safety protocols, meaning radiation exposure had to be kept as low as reasonably achievable. Now, what's really interesting about this slide is this incredibly small margin, just 60 centimeters. You have this 36,000-ton megastructure that needs to move 327 meters over the crumbling 1986 sarcophagus. If they made direct contact or even just caused too many vibrations, the old shelter could collapse and release a massive radioactive dust cloud. So they used 224 hydraulic jacks to precisely push the massive arch just 60 centimeters per stroke over Teflon-coated rails. It moved at a painstakingly slow speed of about 10 meters per hour just to ensure absolute millimeter-level precision. Moving on to Section 2, 100 Years of Containment. Once the structure was successfully slid into place back in November 2016, it wasn't just some static dome. It actually became a highly active operational facility designed for the next century. Let's look at the hidden technologies working inside this marvel. The arch features double-walled steel cladding to create a perfect airtight seal. Suspended from the ceiling are dual 50-ton bridge cranes equipped with robotic arms, specifically designed to remotely dismantle the old sarcophagus below without humans ever having to step foot in the hottest zones. It utilizes HEPA pressure filtration to capture any radioactive dust. And, absolutely crucial to its 100-year lifespan, dehumidifiers continuously pump conditioned air between the steel walls to keep the humidity below 40%. This prevents the steel from corroding from the inside out in that harsh Ukrainian environment.
Section 3. Geopolitics and modern threats.
While the confinement brilliantly solves a 100-year problem against nature and radiation, a terrifying new complication has emerged in recent years. It's become glaringly obvious that this structure was engineered to fight the elements, but it was never designed for war. As recorded by the International Atomic Energy Agency, in February 2022, Russian military forces occupied the exclusion zone, disrupting automated monitoring. Then, escalating the danger, February 2025 saw an explosive drone strike directly impact the structure, and just months later, in October 2025, regional shelling caused a complete power outage at the site. So, the crucial point is exactly what happened during that February 2025 drone strike. The high explosive warhead pierced both the outer and inner protective cladding of the arch, creating a 15-square-meter hole. This impact ignited internal insulation materials, resulting in a fire that smoldered for at least 2 weeks. Now, while emergency workers managed to suppress the fire and the IAEA reported no immediate external radiation spikes, the delicate, airtight, hermetic seal of the confinement was severely compromised. And that leads directly to the vulnerability highlighted in October 2025. You see, the new Safe Confinement relies on continuous electricity. Regional grid stability is practically its Achilles heel. When strikes severed power to the Chernobyl site for several hours, the structure lost connection to its external electricity supplies. Why does this matter so much? Because without power, the advanced overpressure system and HEPA filtration networks just completely fail. If those systems stay down, the enclosure risks the mobilization and outward migration of radioactive dust. This brings us to a really stark warning from the International Atomic Energy Agency following these events. They stated that there is absolutely no room for complacency regarding nuclear safety amidst modern military conflict. The new Safe Confinement is an unparalleled achievement of human collaboration, for sure, but its reliance on grid stability and its vulnerability to asymmetric warfare expose the extreme fragility of nuclear safety today. Which leaves us with this final, provocative thought to ponder. Can any engineering marvel, no matter how brilliantly designed or globally funded, truly protect us from the unpredictability of human conflict? The Chernobyl new Safe Confinement conquered the invisible threat of radiation and the forces of nature, but it seems the ultimate test of its 100-year lifespan may very well be humanity itself. Thank you for joining me for this explainer. Keep learning, and I'll see you in the next one.